Hey guys, this is Mr. Teen Tutor here, and today we're going to be talking about a physics concept involving centripetal acceleration. Here's an example problem for you guys. You whirl horizontally over your head a 35-gram rubber stopper 20 times in 17.47 seconds. The rope is 1.3 meters long and the stopper is 2 meters off the ground. There are two parts to this question. One, what is the speed of the stopper? B, what is the force acting on the rope? Before we attack this problem, we need to understand the difference in equations between objects going straight and objects going in circular motion. Let's begin with objects going in a straight motion. How would you calculate the acceleration? That would be the change in velocity over the change in time. But when it comes to centripetal acceleration, the equation is different. It is actually equal to v squared over r, where r is the radius. So that's different. Now, when we talk about velocity in a straight line, it is equal to d over t. For centripetal acceleration, it is essentially d over t, but it's a little bit different. D refers to the displacement, in other words, or as a scalar quantity, the distance. Well, the distance traveled around a circle is known as the circumference. And the circumference of a circle is equal to pi times the diameter. Now, in most physics problems, they usually give you the radius, and the diameter is equal to 2r. So let's sub that in. So the circumference is 2 pi r. So the displacement, if you walk around the circle, is 2 pi r. And that's over time. And we put this as big T, because T represents the time it takes to complete one revolution. Let me write that in, because that is super important. You need to remember that. It's not perfect writing, as you can see, but it's the time it takes to complete one revolution. And before we attack this problem, one more thing. We know that the net force is equal to ma. Well, for the centripetal force, it is equal to the mass times centripetal acceleration. Well, if we know that centripetal acceleration is v squared over r, we just sub that in. So the centripetal force is v squared over r. So before we attack any centripetal acceleration problem, it is important to keep this equation in mind, the FC1, this equation in mind, two pi r over t. It's important to keep that in mind. And it's important to keep in mind the AC equals v squared over r. So you can keep in mind this equation, that equation. That will help us solve this problem. So let me erase this now, and then we can begin. Alright, so we are first trying to find the speed of the stopper. So we're essentially trying to find the velocity, which is equal to 2 pi r over t. So you're probably wondering what r is. Well, if we draw a quick picture, imagine yourself whirling this rope around. So the rope stays like this, and you're just twirling this rope around, and you're making this circular motion. Well, then what do you think the rope represents? You would say then that the length of the rope represents the radius of the circular motion. So r in this problem is actually the length of the rope. Think about it, and you'll get it. So v equals 2 pi times 1.3. And here's some physics advice for you guys. Whenever you're attacking a problem, make sure you write out the general equation and then sub in the values. Now, like I said, we have to solve for big T, which is the time it takes to complete 1 revolution. Well, if it takes 17.47 seconds to complete 20 revolutions, then let's take 17.47 divided by 20 to figure out how long it takes to complete 1 revolution. So let's plug that into the calculator and see what we get. I get 0.8735. So big T is 0.8735, and we do another calculation and we will figure out what the velocity is, the speed of the stopper. Turns out to be 9.35 meters per second. That's the answer to part A, and make sure you include your units. And we're going to use this answer to find the answer to part B. You'll see in a moment why. Now part B, we are trying to find now the force acting on the rope. Well, if you remember from my forces in 2 dimensions video, if you watched it, any force involving a rope is called a force of tension. So the centripetal force in this problem, because we're dealing with the rope, is force tension. And as we said, force tension now is, in place of centripetal force, is going to equal mv squared over r. So this is equal to, now, the mass. Whenever it comes to a physics problem and they ask for mass, make sure it's expressed in kilograms. That is super important. In this problem it is expressed in grams. And 1,000 grams equals 1 kilogram. So with that conversion in mind, we will simply move the decimal point 3 units to the left. And when we do that, we get 0.035. So we're going to sub in 0.035 here for the mass. And we found the velocity, which is 9.35, so we're going to square that value. And we're going to put this over the radius, which, like I said, is the length of the rope. So let's plug this into our calculator and we will get the force acting on the rope. The force acting on the rope is 2.35 newtons. There you go. The answer to part A and the answer to part B.